we can start now. Okay. Hello everyone. So my name is Pramod and I'm going to be your instructor for this MLOps course. So today in this video, uh, in this lecture, we will try to understand what exactly MLOps is and why it is needed basically, and which are the tools that comes under MLOps and how it will solve the larger picture or larger problems over there. And in this course, which are the tools that we are going to cover, or what are the things that we are going to learn? So all those things we will understand in coming 1 hour. Okay. So this will be 1 hour demo. If you have any question, anytime you can ask. You can just say stop me, and I will just give you opportunity to ask questions. Okay. Yeah. So before I will start, can you all give me high level background, that from which background you guys are belongs to? So can we start with Manish?
Sure. Am I audible?
Yes, yes, you are.
Yeah, hey, Pramod.
Hi.
So, hey, I have close to 17 years of experience in IT. So,
Mhm.
I lead some DevOps teams, and I do the production management support for most of the banking and insurance companies over here. At this point of time, I do a lot of I do support Kubernetes platforms, Azure and AWS cloud platforms. So I do I lead the migration practices for these organizations. So at this point of time,
Okay.
I wanted to learn something about MLOps because I haven't done anything hands-on on MLOps, and the future I see, you have to do something with MLOps and generative AI. So that is the reason why I wanted to learn this course. So
Okay.
I
Okay.
want to do some hands-on. I was never a developer, but I spend
Mhm.
most of my time with, managing the infrastructure, being the legacy data centers, and few days, I've done some cloud operations. Then I've done some, DevOps practices, SRE. I manage AKS and EKS platforms. So I want to
Mhm.
do something with MLOps these days, and ML and generative AI.
Mhm.
So that is the reason why I'm here.
Okay. Okay. Yeah. Thanks, Manish, for your introduction. Actually, definitely you have a lot of overlapping points between MLOps and your existing career experience. So definitely it will be get like it will be easier for you to understand these concepts. Yeah. Can we go with Kumar? Kumar, I think you have a mic issue or something like that. Okay. Can we go with Ram? Yeah, Ram, can you unmute and help us with your introduction? Okay, looks like there is some issue with Ram as well. No problem. Yeah, we can then start now. So if I will talk about my background, so I have a 7 years of experience in data science field. I work with many startups and MNCs as well. I have started my career as a data analyst, and then eventually I transformed my entire career into a data engineer, and currently I'm working as a data engineer. So I do have experience as a data analyst, machine learning engineer, and data engineer. I have built end-to-end machine learning applications for startups as well. And in MNCs that they don't give end-to-end opportunities, but I have built some legacy projects over there as well. So I have close to 7 years of experience in data science and machine learning operations. Okay, so let's try to understand what is this machine learning and how exactly it works and how it is different from software engineering. Okay, so this is a basic definition of machine learning. I will not explain that definition because it will be too much theoretical. But once this session will get finished, you will have a good idea to understand this definition. So below that, we can see here we have a three boxes or three circles over here. The first one is ML design, second is model development, third one is operation. Okay, So like in normal software engineering, that everybody writes some codes, they develop some applications, or they may be building some mobile applications as well, or websites, something like that. So once that will be built, so we call it as a software design. Okay. So initially that comes there, and after that we do actual coding, that we call a software development. And once that is done, we do some operations. We call it as a DevOps. Okay. So in normal software engineering as well, we have these phases: design, development, and operation. So same three phases here as well. First one is design, but it is a machine learning design. Second is model development. Third one is operation. And this operation is nothing but machine learning operation. So in normal software engineering or traditional software engineering, what we see is dev operation or development operation. Here it will be a machine learning operation. So what we do in machine learning design section basically, so we gather some requirement from the client or maybe from end user. Okay, and once we have a requirement from the client, then we decide, okay, with which requirement we should go first. So it we call it as a prioritization. So we do a prioritization of our requirements, and once that is done, then we are new to any domain. Maybe if you want to work for a customer service domain, or maybe for banking domain, maybe for financial institute domain. So in that case, we are not a expert of that domain. So that's why we need to gain some business understanding of that domain as well. So that comes under domain knowledge. Okay, so we understand that domain basically, and once that will done, then we will ask for some data from the client or maybe from end user, that okay, now we know domain, we know your requirement as well, we know how this industry works. Now I need this amount of data, and these are the features or these are the columns I need. So can you help us with this, with that data? So this entire sections come under machine learning design. So once we have a requirements clear, we know the business knowledge, we have a domain knowledge, and once we have a data as well, then we move towards next phase, which is called as a development phase. So now we have everything, we have clear everything, and now we can start our coding. Okay, so we can do some coding and build some model as well. So like in normal software engineering, we build some applications or we build some websites. So that time we go and write some codes there. But here in machine learning, it is not that simple or not that easy. Reason, the data which we acquire from the client might not be ready to pass to models, right? So we may need to do some processing on that data. So that phrase we call is as a pre-processing phase. So the first phase that comes under model development is data preparation and pre-processing. So if maybe that data does not have a good quality, it may have some inconsistencies as well, it may have some null values, it may have some duplicate values, it may have some irrelevant data. So all these things that we need to figure it out, and we need to do some pre-processing on that data. Once our data is pre-processed, so we can say that okay, now this is a good quality data. Then next phase comes, okay, we may have hundreds of column. So from these hundreds of column, how many columns are actually required, or how many columns are actually giving me a information which will help me to solve a problem, or which will help me to predict something. So there might be 100 columns, but all hundreds are not important. So that finalization of those column, or maybe creation of new columns from existing column, that phase we call as a feature engineering. So here we will understand, okay, we have 100 columns, but which are the important column, which are our actual features, which are irrelevant feature. That phase we call it as a feature engineering. So once we have a data ready, we call it as a data pre-processing phase. Once we have a feature ready, we call it as a feature engineering phase. So now the data which we have after feature engineering phase, that data you can directly pass to model. That data is very high quality data, and it has a predictive power as well. Okay, predictive power means the data which will give us some conclusion, which can give us some information. That data is called as a predictive power data. Okay, so once we have a data with predictive power, we will pass that data to machine learning model, and then model will get trained. and we will have a train model ready for use. Once that will be done, so there are again chances that even though your data quality is good, you are using a very good model as well, but still there might be a chances that model uh, may not perform really good on actual data or real world data. So there are chances that model may fail in real world data as well. So that's why we need a model analysis and evaluation phase as well. So in this phase, what we will do, we whatever model we have trained, we will do the entire analysis of that model. That okay, how this model is performing on testing data, or how this model is performing on data on which it is not yet trained, how this model is performing on outliers. All these things we will do in model analysis, and then we will evaluate this model based on certain metrics. Those metrics can be, let's say, if it is a numerical problem, if your model is predicting some numerical value, so we call it as a regression model. So that model may be giving you matrix evaluation matrix like r square or root mean square error, mean absolute percentage error. So these are the evaluation matrices you can apply over there. If your model is classification model, so maybe it is predicting like true false, yes no kind of situations. So in that situation we may go with confusion matrix, recall, precision. So all these are the different evaluation matrix that we will use to evaluate our model. Once this phase will be done, so we have a model ready and which is evaluated as well. So this model can be shipped to production. But this step is not that easy, because we may frequently train our model, we may need retraining of our model as well. So we can, this is not a one time process that you will train model and it will ship to production. No, it is an iterative process. So today you may build one model, one after 1 month you may need to retrain that model with new data as well. So these iterations need something automation, this iteration needs something to be monitored, and that's why machine learning operations are there. So what we will do in third section, in operations, we will take model from model development phase, we will deploy that model. Okay, but during deployment we will do some automation using CI/CD pipelines maybe. Okay, so here we can use some GitHub action kind of tool or Jenkins kind of tool to automate our pipeline. So once that will be done, our model is now really performing good in production, but still we need some monitoring on top of that, because maybe this model is giving really good prediction today, but there is a chances that that model may get degrade over a period of time. So there can be a possibilities of model degrade, and there are two possibilities because of model can get degrade. We call it as a concept drift and data drift. Let me check if I can write here. Hmm, let's do it like this. Yeah. So there are two things. First one is concept drift and second is data drift. Okay. So these two types of drifts can be there. So what is a data drift? So you can consider like you are predicting some weather parameters for summer. Okay, so you may be getting some temperature value which is very high. Okay, but after summer there will be a monsoon and winter as well, where temperature will not that much high as compared to summer season. Okay, so here our data is changing season to season. Okay, so that's what we call a data drift, that this temperature is very high during this period, summer period, but during monsoon it is going down, and during winter it's going much down. Okay, so this shift of data is called as a data drift. There can be a concept drift as well. What concept drift is? So you can understand that before COVID, um, Amazon or Flipkart may have built some models to understand the requirement of customers. So they may be predicting internally that okay, which kind of customer like which kind of clothes, or they do prefer online or offline shopping. So there were a lot of models. Okay, but before COVID, people were not preferring online shopping, or there were means on there was no trends for online shopping or all those things before COVID. But after COVID, you will see that lot of people has started shopping online. Means everything become online after COVID. So that's what we call concept drift. Because before COVID, these shopping websites were considering that no, in India, out of 100, only 40 or 30% people are preferring online shopping. But after COVID, that concept has been completely changed, and now almost 60 to 70% people are preferring online shopping. So these kinds of drifts are called as a concept drift. So these are very real world scenario where data drifts or concept drift can be happen, and that's why we need model monitoring. So the model which you deploy today, it is not necessary. It will perform with the same efficiency next month or maybe after 6 months. So we need to do a continuous monitoring of that model. But what we will do with continuous monitoring? So what we can do when we are figuring out, okay, this model is not performing good, it may have some concept or data drift. So what we can do there, we can immediately do a retraining of our model, and that can be happen on certain parameters which we are going to monitor. And once we know that okay, the model needs retraining, we will trigger retraining. And again, model will means from model development phase, retraining will happen and new model will push to operation phase. So operation will have a new model which is trained with latest data. So these are the things that comes under machine learning operations. Although theoretically we call this third phase as a MLOps, this one is a MLOps theoretically, but work of ML engineer is start from here only and it goes till here. So during model development phase as well, there are a lot of things that MLOps engineer has to perform, like this experimentation phase. So if you are doing with experimentation of models, so that time as well MLOps person will get involved. Yeah, but theoretically we say that third phase is owned by machine MLOps engineers, but in practical, MLOps engineer is involved across entire life cycle of machine learning models. Okay, yeah. Now we can see the life cycle of machine learning model. So we earlier break down that entire life cycle into three parts, but now let's understand how in deep how or maybe in deep drive how those all three phases are working here. So we can see here machine learning operations start with this page. Let me change its color maybe. Yeah, now it is white. So this is a EDA phase. EDA means exploratory data analysis. So once we have a data, we do a exploratory data analysis to explore that data. Means we may not be aware about the data earlier from which industry it is coming, what kind of values, what kind of column it has. So we will understand that data here. We will explore some hidden features or hidden inputs of the data. We will find out some irregularities or maybe some unexpected value from this data by exploring this data. So this is very important phase for MLOps engineer or for machine learning engineer as well. Whenever we start with any machine learning project, we should spend like almost 40% of time for EDA, exploratory data analysis. So once we are very much familiar with data, now we can go ahead and do some pre-processing for that data. So
So who,
pre-processing may involve,
sorry,
sorry, yeah,
who
no
has to
problem.
do this exploratory data analysis? It would be the ML
That is
engineer, right?
mostly done by data engineers or machine learning engineers. Yeah,
Not with
MLOps
MLOps.
engineer, not with MLOps engineer. No, no. I'm explaining complete life cycle of machine learning model. So it is owned by machine learning engineer, data engineer, and MLOps engineer as well. Yeah. So from this portion is mostly owned by data engineer and machine learning engineer. Then this one is owned again by data engineer and machine learning engineer, where they will pre-process this data. Maybe they will remove some null values, duplicate values, irrelevant values, or inconsistency in the data. Once that will be done, it will pass to feature engineering. Here mostly data scientist works. Yeah. Reason feature engineering is very much complex and it needs much more mathematical background as well. So that's why here someone who has very expertise in mathematics and statistics, those persons works for feature engineer. But nowadays, machine learning engineer are also working on feature engineering. Then that next portion comes feature selection. So here we may have created some feature, but still we may want to select some relevant feature based on certain parameters to pass to our model. Once this step will get done, the model will shift to model training phase, and it has a hyper tuning as well. So what is the, like, why it is difficult, or why it is like complex model training? Reason, you may have same data, and you may have numerical data maybe, but there are lot of machine learning models are available. There can be a simple linear regression model available, there can be a ANN model available, there can be a random forest regression available. So there are a lot of algorithms or models available. Okay, so we are not sure for which model our data will perform good, or which model will give us a good predictions. Okay, then let's say now we finalize this model is giving you a good prediction. Again, in this model there are a lot of mathematical parameters that we can adjust and increase the accuracy of that model. Okay, so that's why this page become complex, because first of all we need to finalize which model is performing good. So we have to try with each and every model. Once that will be get done, then we need to fine tune the model which we selected. So there may be a mathematical parameters that we may need to tune to increase the accuracy of model. And here we need to do lot of experimentation, and this experimentation takes lot of time, energy. Along with that, in currently machine learning engineer or data engineers are not efficient or not able to track all those experiments. Okay, and that's why there are some tools to track those experiments like MLflow and DVC. So why MLflow and DVC is needed over there? So if you understand, let's say if you have built one model, let's say it is a simple linear regression model, and it is giving you a good accuracy for some hyperparameter. It is a P1, it has a value, let's say 8, 8.5. Okay, then tomorrow you may did some another experiment with this model, and you found good accuracy for parameter P1 8.5 and P2 9. Then day after tomorrow you may did some another experimentation with P1 P2 of different values. Again you may build new model, and that is that can be, let's say, random forest model, and it has some different parameters. Okay, so now it is becoming difficult for you to remember. Okay, in first run which model I used and what was the value of P1, in second run which model I used, what was the value of P1 P2, third one different, even though if you will write this in Excel sheet as well. But again there are chances that for this time you may have used different data, that can be a data 1. For this time you may have used data 1, and for these two times you may use data 2. So data 2 and data 1 will come from this section, that one person is suggesting to go with data 1 because he found these features are important. Another one is suggesting these data 2, because as according to his expertise, data 2 has a more predictive power. So we may have a different data sets as well, we have a different models, we have different parameters for each model, and that's why it becomes very much difficult to track all of these things. And here we need MLOps engineer who will help us to track all those things and who will help us to do this experimentation. But this experimentation and this tracking will be done automatically by setting this ML flow or DVC pipeline. Okay. So once this phase will finish, we will move toward model evaluation phase, which is also automatic phase, which will give us some report that okay, how this model is performing for training data and for testing data. And then from here, if we have a good confidence with our model, we will ship that model to a production. So now before shifting that model to production, we need some UI to interact with that model. So that's why we will build some UI. So again, this section is owned by front-end engineers mostly, but but if it is a very small UI that is required, so MLOps engineer can also develop that UI using Flask application. So what is Flask? Flask is nothing but microwave framework. Flask is called as a microwave framework. Yeah. So if you are from Python background, you may have heard about Django. Okay. So Django is useful to build a complex web applications, but Flask can be used to build a simple or small web applications, and it is very easy to write as well. So once this phase will done, we will move toward deployment phase. Okay, and this deployment phase will have a CI/CD, it will have a Kubernetes, it may have a Jenkins, it may have a model monitoring and model retraining as well. And accordingly, if we found that okay, model needs retraining, then we will trigger retraining, and that will go again through these all phases if we have a new data. Okay, so this is a iterative process, and that is why it becomes complex, because it is not a one time process. You build model and it now you can just rest and model will perform good. No, you have to continuously upgrade your model, you have to continuously monitor that model, and that is the reason MLOps engineers are needed, or machine learning operation technologies are required. Many times people say DevOps and MLOps are almost same. I will say yeah, it is right. DevOps and machine learning is almost same conceptually, yeah, but practically they differ a lot. Reason: machine learning is depend on data, and data changes, means at every second. Okay, every second we have a different data, we have a new data as well, and that's why as compared to normal software engineering, machine learning operation needs a lot of iterations, because here in DevOps, if you have some software or if you have some web application, it may need some changes based on client inputs or maybe based on new requirements only. But in machine learning model, we need a frequent changes uh, because of some upgrade in data, because of some concept change, because of some data change, because of some data drifts. So all these parameters are there which affects machine learning model to degrade its performance. Okay. So far we have a good understanding that what is machine learning, what is the life cycle of entire machine learning model. So now we understand that why MLOps is required. What if MLOps is not there? What are the issues that people are facing without MLOps? So as I already mentioned, it is an iterative process. That's the main requirement, that we need something automation, or we need something that will handle this entire life cycle again and again. But if we don't have MLOps practices, then what are the issues that we face? First one is a low coding standards. Okay, so currently, even though people are building some models, they are thinking like okay, I will build model, it will go to production. No, but we have to build with mindset that this is an iterative process, so that you have to be you have to write code with some standards so that that code can be utilized again and again. So like modular coding is very much important, so that you can use particular section of code for new application, or if you want to make any changes, then you don't need to go to the main file or entire code. You can simply go to that module and make some changes, so that will become easy to make changes in entire life cycle. So modular coding is missing nowadays. Again, we login and exceptions are also something that people are not using efficiently. So these are the some issues that we face under low coding standards. Then there is no data management. So like we don't have a we have receiving data from particular resources, but we are not managing those data in standard applications. So it can be a data warehouse, it can be a data lake, it can be a normal database, it can be a feature store as well. So nowadays people are directly taking data from maybe web scraping or maybe from databases as well. But we should understand, okay, from which scenario or for which use case we should use data lakes, we should use data warehouse, or whether feature store is required or not. Okay. Then third is a versioning. So if you are from an IT background, so you may be already aware about code versioning that we do with Git. Yeah. So there are Git clients as well, like GitHub and Bitbucket. Yeah. So these are the Git clients. Those help us to version our codes. But for machine learning, we apart from code, we don't have only code. We have a code, along with that data, along with that model as well. So we have a three things to version. Okay. So can we do this versioning with GitHub or Bitbucket? No. Reason, GitHub and Bitbucket has a size limit. You cannot upload a size which is more than, I think, 25 MB or something like that. There are limits for GitHub and Bitbucket. So if you have a data with 1 TB, how you can upload that data to GitHub? So that is not possible, and that's why we cannot version our data, right? Data in GitHub. Same model as well. Models are also with a larger size, so it can be of 1 GB or 2 GB model that we cannot push to GitHub or Bitbucket. And that's the reason we need something to version our data and model apart from GitHub. So that's where DVC comes into picture. So this DVC is nothing but data version control. Okay. So using DVC, you can use S3 bucket or maybe cloud storage to version your data. In simple case, we can even use Google Drive to version our data. Okay. Then there is a data or pipeline experimentation phase, which is also missing because it is not automated. So if you are doing some experiment, those are not tracked efficiently, and that's why after some period of time we may forgot, okay, which experiment was giving me a good accuracy, or I know that, okay, I got 90% accuracy, but when I got a 90% accuracy, which model I use or what was the parameter of that model. So it's difficult to remember or difficult to track all those things. And that's why we need an automated pipeline to manage those experiments. Okay. So here ML flow will help us to track those experiments. Then we are lagging of CI/CD concept, because even though DevOps is very mature field, but still a lot of people or in a lot of companies, CI/CD pipelines are not efficiently managed or not efficiently created. Okay, so in MLOps is very new field, so obviously in MLOps CI/CD concept is lagging. So that is one of the issue that we face without MLOps practices. Then scalability and monitoring in production. So it is same like DevOps concept. Like if you want to scale our model, maybe you have a one model which is capable to handle 1000 customer, but maybe because of some market changes, your customer has been increased and it has been reached to 1 lakh. So this model is not capable to handle 1 lakh customer. That's why we need a scaling of this model, and this scaling that we handle using Kubernetes. So there are auto scaling as well, which will trigger automatic scaling and automatic descaling of our models. Then Prometheus and Grafana that we can use for model monitoring. But to monitor model efficiently, there are some basic or there are some core machine learning operation tools that we can use to track our models. And then cross team friction, because there are a lot of teams nowadays. There are data engineers, machine learning engineer, data analyst, AI engineer. In some companies they have specialized computer vision engineer, and then we have a machine learning operation engineer. So it becomes like difficult to interact or difficult to collaborate with different teams, and that's why we need MLOps practices which will help us to efficient collaborations. Okay. So this is a diagram of normal software development life cycle. If you guys are already from software development background, so you are already aware about it, that we have a development, we have an operation phase. In development phase, we do a development testing and some QA analysis. And once that testing QA analysis will done, we will send this web application or software to operation team, who will take care of delivery, deployment, and maintenance as well. Okay, so I don't need to I should not speak more about it, because if you are already from IT background, so you guys are already aware about it. Yeah. So what are the tools that are used for machine learning operations, or for maybe complete machine learning life cycle? Okay. So you can see these are the tools, and it is even difficult to remember these tools. So it will be obviously difficult to learn all these tools. Okay. And that's the reason we again need a standard MLOps techniques, so that we can use some tools which are open source, which are easily available in market, or people have expertise, those people are available in market, and we can easily integrate those tools with our existing system. So obviously you can see here in data exploration phase only, we have a lot of tools available. Let me change color again. Yeah. Here we have a lot of tools available, but we need to find it out which are the tools those are efficient or those are fulfilling my requirements. Similarly, here in data labeling we have different tools, data streaming we have different tools, data version control we have different tool, and as I mentioned about DVC, which is very popular here, so that is mentioned here. Then we have a data generation tool, data privacy. Means there are a lot of tools in machine learning, but we need to find out some tools which are standard and which are easy to integrate. Along with that, there is expertise in the market for those tools as well. Okay, so what are the tools that we are going to explore? Let me tell you here. Yeah. So for code standardization, we are using modular coding. Uh, let's change color again. Okay. So for code standardization, we are going to go with modular coding. We will be using logging. Okay. Then we will be using this artifact and component pipeline management as well. How we can efficiently manage them using a modular coding. Okay. So that we are going to learn in this course. Then second is core versioning. So here we are already aware about Git and GitHub, if you guys are aware about Bitbucket as well. So here we will be using GitHub Action for CI/CD. Okay. Then third is a data or model versioning. So here we are heavily working with DVC and MLflow, because these are the core component of machine learning life cycle or MLOps life cycle as well. Because these tools will start monitoring your model or data from the initial phase till it will get deployed to the production, and even after deployment as well, these tools will monitor your model continuously. Okay, so these are the tools that we are going to cover in this course. Along with that, there are a lot of tools, Neptune, Seldon, Kubeflow, and GenML as well. So if time permit or if there will be requirement for any project, so we will try to use any one from these as well. Then we will use CI/CD tools. So as I already mentioned, we will work with GitHub Actions because we will be using GitHub to store our codes. So GitHub Action will be easy to integrate over there. But there are some Circle CI and Travis CI as well. I have worked with Travis CI, but let's see. We in this course we will only explore GitHub Action. But if there will be like interest or if time permit, we will try to cover this as well. Yeah. Then next will be containerization. So we already aware about how we containerize software applications, but here we will learn how we containerize machine learning model. Okay, because that is difficult or complex than normal software code, right? So here we will learn how to dockerize the machine learning model, and we will use Docker Hub as well here. The next section is scalability and monitoring. So here we will be using Kubernetes to manage the scalability of our model. And of course, Prometheus and Grafana, definitely it will be coming to monitor our model. But along with that, we will be going to use some open source tools from AWS, open source tools which are not available on AWS or GCP to monitor our models. So there are a lot of tools. So I will figure it out that which tools we can go with or which are the open source available. Then we will use some AWS services, so like IAM user or creating ECR, S3 bucket, EC2 instances. So all these things we will try to create or we will utilize to deploy our machine learning model on AWS. Okay, and even though we will set model retraining on AWS as well using some parameters over there. Okay, yeah. So this is all that we are going to cover in this course, and these are the all tools and techniques that we will be discussed in coming lectures. Yeah. All-in-one services is AWS SageMaker, Google Vertex AI, and Azure ML. So these are some platforms like AWS, GCP, and Azure ML. They also provide some machine learning things where we can also do some machine learning, but obviously they are very much complex, expensive as well as compared to open source applications. Okay, yeah. So this was all about for this demo. So in this slide you can see that these are the technologies and these are the concepts that we are going to explore in this course. So if you have any question you can now ask me.
But don't we use a Ray framework? Have you heard of Ray framework?
Ray framework,
Yeah,
what is the purpose of using them?
for scaling the machine, ML applications.
Oh, okay. It's I think it worked like a PySpark, right? I did not work with Ray framework, but it's like a PySpark to work with the batch coding, right?
I think so. Yeah. So, and one more thing, when you say you're containerizing the ML module, right? So, who has to do the containerization part?
MLOps engineer.
Okay, not the developer, ML engineer.
Uh, if developer has a skill they can do it, but since MLOps engineer know what to do next after containerization model or what kind of features that we need to add during containerization, so it's better always machine learning operation person will do it.
But the future
But
part,
again
we don't know it, right? We don't know the future, right? What feature to add and all, right? MLOps doesn't know what feature to add, right?
No, MLOps is not completely blind about feature. MLOps engineers is aware about feature that okay, these are the features that model has trained, because then only we can monitor our model, right? If we know features, then only we can monitor our model. But we are not aware about okay, we know that these are the features models is using, but we may not be aware about that okay, what is the predictive power of that feature or what are the values inside those features. We are not completely aware about that. And for containerization part as well, it's again depend on company to company, or I will say manager to manager as well, that how they are going to take that portion, like they want to ship it with MLOps team, or they want to continue with machine learning operation teams. Yeah, anybody? Any question? Nagraj, are you there? Okay. If no question, then we can close this session. And let me inform you that if anyone is already familiar about Python, then there is a batch which is starting on coming Tuesday. So that batch is already started, but before that we were covering some Python portion of the like basic Python, which is required for machine learning operation. So that Python we have covered so far, and from coming Tuesday we will starting with machine learning. So if anyone is not familiar about machine learning but familiar with Python, they can join from Tuesday. Reason being, from Tuesday we will cover with some basic machine learning as well, so that you will get familiar with machine learning concept before applying it to MLOps.
How, how,
Okay.
how
Yeah.
extensively do we use Python in MLOps?
I will say like 100% Python is there only. We don't use any other language apart from Python. So we use heavily Python for machine learning operations.
So where in this one, or where in this flow do we use the Python?
In this flow,
Yeah,
yeah,
yeah.
like I for DVC or ML flow, these pipelines will get created using Python only. So entire pipeline is part of it is written in Python. Even though model monitoring or model retraining is also written in Python.
Okay.
Yeah.
So you say ML for Python pipeline basically.
Yes, DVC and ML flow are the Python pipelines, and model retraining and model monitorings are also Python pipelines. We call it as an inference pipeline as well. That is also part of Python.
Okay, these pipelines, right? Should be
Mhm.
written by ML flow pipeline should be written by us.
Uh, yes, some part of ML flow pipeline should be written by machine learning operation engineer. Reason, once it will get model will get trained. After that, also ML flow will come in picture for ML of operation, where model will get deployed, where model will get monitor or scaling of the model. That will also handled by that portion, that ML flow.
Do you have a sample ML flow, a pipeline by chance handy? Just wanted to see it.
Like you,
How is it going?
code I don't have a handy, but I can share it with you if you can just ping your email ID here.
Yeah, sure.
Yeah.
Let me ping it to you. You are
Okay.
Pramod, right?
Yes.
How do I ping you? Do I have the uh, where is it? Where is the chat facility over here? Do you have one?
It's top right. Top right.
Okay, okay.
Do you have top right chat option?
So this is wallet. Okay,
So
wallet is shown.
yeah, I can see one message. I have seen.
So what are the job opportunities for ML engineer these days?
This is actually very generic question, by the way. But if I will say for machine learning operations, there are like people don't have much skill in machine learning operation nowadays. So there are lot of openings. Reason, machine learning field has been started growing since 2017 and 18. So now all companies have a lot of models, and they need these techniques, machine learning operation techniques, to efficiently handle those models. So day by day models are increasing in companies, that's why they need machine learning engineers. So I will say for MLOps engineer, but they are mostly looking for MLOps engineer who have a software engineering background. They like almost 5 7 years of experience in IT, so that they can use their existing knowledge for machine learning as well.
So
So
how about a
jobs are
DevOps
there.
getting moved into? How about a DevOps guy moving into MLOps?
Yeah, actually, in the starting at the starting of the section as well, I mentioned that DevOps and machine learning operations are very closely related. Here in machine learning, we use models to operate them. In DevOps, we use software applications or web applications, and then we manage the operation of those applications there. So it is closely related. Just there we use web application. Here we use models.
Yeah. Okay.
Yeah, concept is almost same and life cycle is almost same. So if you, as you mentioned, you are coming from DevOps background, you may be aware about Kubernetes, Prometheus, Grafana, GitHub Action. All these things you might be already aware about. So there are a lot of overlapping technologies between them.
Yeah.
Okay.
Yeah. Bye.
Okay, if anybody has any question, if not, then we will close this session.